My fabulous chemistry minions, video 3. Let's get into the nuts and bolts of redox. And this is the first vital, super important task you have to be able to do: assign oxidation numbers. Okay. Overall rules for oxidation numbers with elements and compounds. So, oxidation is losing electrons. There's oil. Rig, reduction is gaining electrons. That is the one I use. I use oil rig. I'll write it on top of my paper. You can use Leo says Gur. I will not give you a hard time for using Leo says Gur. You just need to know that. If there is a reduction, there must be an oxidation. If there is an oxidation, there must be a reduction. They go hand in hand. They must have both. You cannot have one without the other. I cannot stress that enough. Okay? And both happen also at the same time, always. They are constantly going on. This is a cool reaction. So, assigning oxidation numbers for pure elements, this is easy. All lone elements are 0. So, let me show you. Here's Ca. It's going to be 0. That's what you're going to put above it. If you see an element all by itself, if you see Al, you're going to write 0. So I'm going to teach you that the first elements that we ever, when we start assigning oxidation numbers in an actual full reaction, I'm going to go after those lone elements first, and I'm going to put zeros on them. And that's where I'm going to hunt first, and I'm going to go on to everybody else. Remember, ions are not elements. Their oxidation number is their charge, and at some point in the practice, we're probably going to have to assign oxidation numbers to atoms within a polyatomic ion. And I think that's actually, it's in the POGL, and it'll teach you how to do that. But I mean, I'm a teacher right now that then the overall charge is going to be the charge on the ion, where we're going to learn now in compounds that the overall charge is 0. And this one slide took me 3 hours to animate. So let's hope you enjoy, and let's hope I can teach it properly from home. Ready? So we have 2 ways to identify the oxidation numbers within a compound. First, we can simply uncrisscross. I taught you guys to crisscross down the charges, so we can take the subscripts and bring them up to show the charges. Sorry, I hear the puppy going crazy upstairs, so if you guys hear, sorry. And then we use full charge cancellation to determine the charges. So the first example I'm going to do is going to be an uncrisscross, and we have a lot of experience with that, I think, because we have some experience with crisscrossing, so that's easy. And then the full charge cancellation, I'm going to take my time with and do 3 full examples, part of the reason why it took me so long. And then what we need to know is, if it's a compound, by definition, its overall charge has to equal 0. So we're going to use that to our benefit, especially in the last 3. If it is a polyatomic ion, which I don't think is part of these notes, then its charge equals the charge on a polyatomic ion. Okay, guys? So I hope you are listening, by the way. No bumping while we're doing this. So, first example, calcium chloride. I'm just going to simply uncrisscross these. So I request that you watch each example before you write it, because there's going to be a lot of moving parts. Okay, so this is how I uncrisscross. First, I get my elements, and then I literally just take the 2 and bring it up, boop, and then there's a 1 on the Ca. Without writing it, there's a 1, and that 1's just going to come up here. And I remember that always that the first element is plus and the second element is minus, and we're ready to go. It's that simple. And if you look on the periodic table, which I did not provide you here, Ca is a +2 charge with no other choice, and Cl's first choice is a -1. So there we go. Got the first one done. Now we're going to get into full charge cancellation, because the reagents is going to give you somebody like this. Generally, this I can't just uncrisscross because there's 3 elements. So this, I'm going to use the full charge cancellation method here, and I'm going to pull up some elements for you to see why and what's going on. K, potassium, look, only has 1 charge. Nice. Oxygen only has 1 available charge, -2. Good. Mn, ooh, could be a +2, a +3, a +4, or a +7. Ouch. I don't know which one to pick, right? Who does? We're going to use some simple math and some algebra to figure that out. So what we're going to do is we're going to start with the K and we're going to start with the O, because they only have 1 choice. Okay, guys? Start with what you know. Okay, so I'm going to start with the K. He's a +1. And as I look down and I multiply down, and I've done this before with you guys on the smartboard, there's only 1K. So there's a +1 charge, and then the 1 times 1 is times 1 element. There's only one of them. So that's going to leave me with a 1. Perfect. Now I'm going to do the oxygen because I know that it's a -2 charge. And if I multiply that by 4 of them, now I get a -8 charge. Now here comes the trick. We know that they all must equal 0. So I can do just a little bit of algebra. I can say 1 plus x minus 8 equals 0. I mean, just because there's multiple numbers in there doesn't mean that you guys can't solve that using your algebra rules. I personally like to group because that's how I do math fast. So I would take the 1 and the x and group it together, and then the -8 equals 0 and keep that separate because I know any number -8 equals 0, that any number has to be 8, right? I would need the answer to be 8 minus 8 equals 0, right? And you guys know this. This is simple math. So now I can group that together now and say 1 plus x equals 8. And if 1 plus x equals 8, that's a lot easier in my head. Otherwise, I have to add 8 and then subtract 1. But you can do it the long way too. And I didn't animate that all out. I could add 8 to both sides and then subtract 1 from both sides. And either way, I'm going to get 7. So when I solve for x, that x is the charge on Mn. And there we go. I look up, Mn's got a possible charge of 7. We're all set. Very rarely are you going to find a charge on an element that doesn't exist on the periodic table? That may happen. I'm not going to lie. It might happen. If something happens like that, you need to just check your math and go with your math. Your math is right. Okay. And there is the first full example. I have 2 more of these that ad nauseum go just like that. Ready? Here we go. So I'm going to do KClO2. At least we have some common elements here with the K and the O2. But again, Cl has multiple charges and I don't know what it's going to be, but I'm going to use the K and I'm going to use the O to help me figure out what the charge is on the Cl because I'm going to go with what I know. So again, the K is the 1 and I only have 1 K, so its total charge is 1. And the O is a -2 and I have 2 of them, so that total charge is going to be -4. Now, algebra, solving for x, I know 1 plus x has to equal 4 so that I get 4 minus 4 equals 0. 1 plus x equals 4, x equals 3. Bring that 3 right up to my charge, and I have assigned oxidation numbers now using the full charge cancellation method. You got one more to do, and I think this video is donezo. So let's crank through this right nice. Video takes a lot less time to make than actually animating this PowerPoint all out, let me tell you what. But I am kind of proud of it, and I hope that it works. And at least when I say works, helps make it so you can understand what's going on. So again, same elements involved in this example as the other one. Notice the oxygens have just increased. If the number of oxygens have increased, the charge is going to change on the Cl. So I go with what I know. I know K is a 1, and I only have 1 of them, so its total charge is +1. I guess I could add a positive in there. -2 times 4. In this case, there's 4 oxygen, so I'm multiplying that -2 times 4. I get -8. Again, some algebra right quick. I know that 1 plus x must equal 8, so that I get 8 minus 8 equals 0. So if I group it that way, 1 plus x equals 8. And it happens, it's easy to do that. And it's not even that it's a trick. If I were to just add 8 to both sides, it would literally say 1 plus x equals 8. Okay. So it's kind of just following the first step. I'll find out that x equals 7 again. 7 goes to my middle element, and we are donezo. So I think that now we can assign oxidation numbers. What you need to know is, of course, lone elements get 0 because they have the same number of electrons and protons. Within compounds, we need to uncrisscross or use the full charge cancellation method to determine what our oxidation states are. What I did not do for you is do a polyatomic ion. That'll happen in the POGL, and you'll see what's going on there. The only difference there is that instead of the charge equaling 0, the charge will actually equal -1 or -2 or +1, whatever the charge is on the ion. With that being said, we're done. See ya. Maybe not see you. Try again.